Imagine waking up to headlines warning that a massive asteroid, named after an ancient god of chaos, could be on a collision course with Earth. For a brief moment in 2004, that nightmare scenario felt all too real. But what if I told you that this cosmic threat not only changed the way we see our place in the universe, but also united scientists, governments, and ordinary people in a race against time? The story of Apophis isn't just about danger from the skies, it's about discovery, resilience, and the power of human ingenuity. If you're fascinated by the mysteries of space, the science of planetary defense, and the real stories behind the headlines, make sure to hit that subscribe button and turn on notifications. Join us as we explore the universe's biggest questions and the ways humanity is preparing for whatever the cosmos throws our way. Don't miss out on our next deep dive. Subscribe now. In the early spring of 2004, a team of astronomers working at the Kitt Peak National Observatory in Arizona noticed a dim, slow-moving point of light drifting across the night sky. At first, it seemed like just another minor object among the countless asteroids catalogued every year. But as they tracked its movement and calculated its path, it became clear that this was no ordinary find. The object, later designated as 99942 Apophis, was on a trajectory that intersected Earth's orbit. This discovery would soon become a global sensation, sparking headlines, public debate, and a renewed focus on the risks posed by near-Earth objects. At the time, no one could have foreseen how much attention this single asteroid would attract. Apophis quickly became the center of one of the most intense periods of scientific scrutiny and public fascination ever directed at a space rock. The reason wasn't just its size or its proximity, but the unsettling possibility that it might actually collide with our planet. For many people, this was the first time they truly considered the vulnerability of Earth to cosmic threats, and how easily our sense of security could be shaken by events unfolding far beyond our atmosphere. Once Apophis was identified, astronomers wasted no time in running detailed calculations to determine its future path. Using Newtonian physics, gravitational modeling, and advanced computer simulations, they tried to predict where the asteroid would be in the coming decades. The initial results were alarming. Based on the limited data available in 2004, there appeared to be nearly a 3% chance that Apophis could strike Earth in April 2029. While 3% might sound small in everyday terms, in the context of planetary defense, it was an astonishingly high risk. Most asteroids that cross Earth's orbit are quickly ruled out as threats, with impact probabilities closer to 1 in a million, or even less. But a 3 in 100 chance was a different story entirely. The scientific community and space agencies around the world realized that if these early calculations were correct, Apophis represented a genuine, near-term existential threat. The asteroid's size only added to the concern. Measuring about 340 meters across, Apophis was not large enough to cause a mass extinction like the asteroid that ended the age of dinosaurs. But it was certainly big enough to inflict catastrophic damage. An object of this scale carries the energy of tens of thousands of nuclear bombs. If it were to hit land, it could wipe out a city or even devastate an entire region. If it struck the ocean, the resulting tsunamis could destroy coastlines thousands of kilometers away. The destructive potential was undeniable, and combined with the initial high probability of impact, the world suddenly had a reason to pay close attention to a space rock that had previously gone unnoticed. The name chosen for the asteroid only heightened the drama. Apophis is named after the ancient Egyptian deity of chaos, a serpent said to threaten the sun each night as it journeyed through the underworld. The symbolism was hard to miss. A god of chaos discovered in the sky, possibly on a collision course with Earth. The story practically wrote itself, and the media quickly seized on it, producing sensational headlines about a doomsday asteroid. Some news outlets exaggerated the risk, suggesting that an impact was almost certain, rather than a small but real possibility. The public, already primed by Hollywood movies like Armageddon and Deep Impact, found it easy to imagine scenarios where humanity would have to launch desperate missions to save itself from annihilation. For many ordinary people, the discovery of Apophis was the first time they were confronted with the idea that civilization-ending threats are not just relics of the distant past or the stuff of science fiction, but can emerge suddenly from the darkness of space. For scientists, however, the discovery was not a reason to panic, but a call to action. Calculating the orbit of an asteroid is a complex process, and the early 3% estimate was based on a relatively short observation arc. The path of an asteroid is influenced not only by the gravity of the Earth, Moon, and other planets, but also by subtle effects like the way sunlight heats its surface and causes it to emit energy, a phenomenon known as the Yarkovsky effect. When an asteroid is first discovered, astronomers have only a small segment of its orbit to analyze, which means predictions are subject to significant uncertainty. The only way to reduce that uncertainty is to keep tracking the object, gathering more data, and refining the calculations. That's exactly what astronomers around the world began to do. Observatories across North America, Europe, and Asia dedicated telescope time to Apophis, feeding new measurements into computer models in hopes of clarifying its future path. What made Apophis especially concerning was not just its 2029 trajectory, but the possibility of what astronomers call keyholes. A gravitational keyhole is a tiny region of space, sometimes only a few hundred meters wide, such that if an asteroid passes through it during a close encounter with Earth, our planet's gravity will nudge its orbit just enough to set it on a collision course for a later date. For Apophis, scientists realized that if it passed through a keyhole in 2029, it could be redirected toward a devastating impact in 2036 or beyond. Suddenly, the problem was not just about one date in 2029, but about the long-term relationship between Earth and this wandering giant. This realization created both urgency and anxiety. Even if Apophis missed Earth in 2029, could it come back around to strike a decade later? The uncertainty was enough to push planetary defense into the spotlight of public policy. In response, space agencies began to take the issue more seriously than ever before. NASA's Near-Earth Object Program Office, which had operated on modest budgets for years, suddenly found itself at the center of global attention. The European Space Agency also ramped up its efforts to track and model asteroid orbits. Apophis became a rallying point for the importance of sky surveys and space observation programs. If a 300-meter asteroid could surprise us in 2004, how many others were still lurking in the darkness, waiting to be discovered? Apophis transformed the abstract concept of asteroid risk into something immediate and urgent. As more observations were collected in 2005 and 2006, astronomers were able to refine the asteroid's orbit with greater precision. Each new data point adjusted the numbers slightly, narrowing the uncertainty. By 2006, the probability of a 2029 impact was effectively ruled out, and by 2013, even the risk of a collision in 2036 had been dismissed. Apophis was officially removed from the risk lists maintained by both NASA and ESA, and scientists could finally assure the public that it posed no threat for at least the next century. Yet, even though the danger had passed in a technical sense, the memory of that initial 3% probability lingered. People remembered how quickly an ordinary day in 2004 had turned into headlines about a possible impact in 2029. They remembered the fear, the speculation, and the debates about what humanity could do if the worst happened. The discovery of Apophis left a psychological mark, a reminder that while we were safe this time, we might not be so lucky with the next one. The anxiety that surrounded Apophis also sparked a wave of discussion about what humanity could actually do if a real threat from space was detected. Could we launch nuclear devices to shatter an incoming asteroid? Would it be more effective to nudge it off course with a spacecraft, like a cosmic game of billiards, or perhaps use a so-called gravity tractor, a spacecraft that hovers near the asteroid, using its own gravitational pull to slowly alter the rock's trajectory over time? These ideas, once the domain of theoretical papers and science fiction, began to be taken more seriously by space agencies and policymakers. The possibility, however remote, of an actual impact in 2029 made it clear that planetary defense could not remain a purely academic concern. It needed to be translated into real strategies, technologies, and contingency plans. On the cultural front, Apophis became something of a phenomenon. Internet forums buzzed with speculation, television programs ran dramatic features, and conspiracy theories flourished. Some people claimed that governments were hiding the true danger, while others insisted that secret missions were already underway to destroy the asteroid. The asteroid's evocative name made it easy to weave into apocalyptic narratives, but it also provided a unique opportunity for scientists and educators to engage the public. Astronomers used Apophis as a teaching tool, explaining orbital mechanics, impact probabilities, and the importance of ongoing observation programs. For many students, learning about Apophis in the classroom became a gateway into astronomy, planetary science, and engineering. The fear of destruction was real, but so was the spark of curiosity and the drive to understand the universe more deeply. The story of Apophis' discovery and the initial fears it provoked also highlighted the delicate balance between science and communication. When astronomers release their early calculations, they face a dilemma. On one hand, transparency is crucial. The public deserves to know about potential risks, and other scientists need access to the data to conduct independent analysis. On the other hand, early calculations are often highly uncertain, and sharing them without sufficient context can lead to panic or sensationalism. In the case of Apophis, the news that it had a 3% chance of hitting Earth in 2029 spread rapidly, often stripped of the nuance that those probabilities were based on limited data and subject to change. The result was a media frenzy that painted the asteroid as a looming apocalypse. This episode taught both scientists and communicators valuable lessons about how to convey risk responsibly, how to explain probabilities to the public, and how to strike a balance between urgency and reassurance. In the years that followed, the discovery of Apophis proved to be a turning point in the field of planetary defense. It underscored the importance of early detection, rigorous observation, and international collaboration. It revealed the gaps in our preparedness and inspired new missions and technologies to address them. And perhaps most importantly, it awakened humanity to the reality that asteroid impacts are not just ancient history or distant hypotheticals, but present-day risks that require attention. Apophis will not strike us in 2029, but the shock of its discovery has already changed the way we view our place in the solar system. We no longer look up at the night sky with unqualified wonder. We also look with awareness, caution, and a recognition of our vulnerability. The legacy of Apophis' discovery is twofold. On one hand, it was a false alarm, a scare that faded as more data came in. On the other hand, it was a wake-up call, a reminder that our planet is not immune to the forces of the cosmos. That initial 3% probability may now be a footnote in scientific history, but it was enough to galvanize a generation of astronomers, engineers, and policymakers. It was enough to remind us that vigilance is not optional, that the universe does not bend to human schedules or expectations. The lessons stirred by Apophis in 2004 are not just about one asteroid. They are about the larger truth that our future depends on our ability to see, to anticipate, and to prepare. It is a story not of doom, but of awakening. And that awakening began with a faint dot of light in the Arizona sky that turned out to be a harbinger of chaos, reminding us of both our fragility and our resilience. In the years since Apophis was first discovered and its initial trajectory sparked worldwide concern, the astronomical community has worked diligently to refine our understanding of its orbit, physical characteristics, and the true nature of the risk it poses. Today, the scientific consensus is much clearer than it was in 2004. And that clarity brings both reassurance and insight into how we approach planetary defense. Current scientific understanding of Apophis tells us that it will not strike Earth in 2029, but it also provides a fascinating opportunity to study an asteroid up close, to test our models of orbital dynamics, and to demonstrate the effectiveness of international cooperation in monitoring near-Earth objects. The process of getting to this point has been long and filled with both technical challenges and breakthroughs. But it illustrates the power of science to transform uncertainty and fear into knowledge and preparation. At the core of the updated understanding is a precise calculation of Apophis's orbit. When an asteroid is discovered, its position is determined relative to the background stars, and those measurements are combined with data from multiple observatories to estimate its trajectory. In the case of Apophis, as additional observations were made over the years, the orbit was recalculated with increasing accuracy. Radar observations from facilities like the Arecibo Observatory in Puerto Rico and NASA's Goldstone radar in California were particularly valuable. Radar is a powerful tool for planetary defense because it provides extremely precise information about an asteroid's distance and velocity. By bouncing radio waves off Apophis and measuring the echoes, astronomers could lock down its path through space with much higher certainty than optical telescopes alone could provide. With this data in hand, orbital models became increasingly refined, and the probabilities of collisions steadily decreased until they were effectively ruled out. One of the most striking aspects of the current understanding is the sheer closeness of Apophis's approach in 2029. On April 13 of that year, the asteroid will pass about 32,000 kilometers from Earth's surface. To put that in perspective, this distance is closer than the orbits of many of our geostationary satellites, which circle Earth at about 35,786 kilometers. For an object 340 meters wide to come that close without hitting us is extraordinary. It will be so close that it will be visible to the naked eye in parts of Europe, Africa, and Asia, appearing as a bright moving point of light streaking across the night sky. For astronomers, it will be a once-in-a-lifetime chance to observe a large asteroid during a flyby of this magnitude, to study how Earth's gravity affects its motion, and to gather data that can improve our models of other near-Earth objects. The proximity is dramatic enough to capture the imagination, yet safe enough to reassure us that this cosmic visitor poses no direct threat in 2029. But how can scientists be so certain about our safety when Apophis will pass so close to Earth? The answer lies in the accumulation of data and the sophistication of modern orbital modeling. When Apophis was first discovered in 2004, astronomers had only a handful of observations spanning a few days. This limited information left a wide margin of error in predicting its future path. As the years passed, and more data points were collected, the uncertainty in Apophis's trajectory shrank dramatically. By 2021, a combination of radar and optical observations had narrowed the possible paths of Apophis so tightly that both NASA and the European Space Agency were able to officially remove it from their lists of potentially hazardous asteroids. This meant that, for at least the next century, Apophis could be confidently declared impact-free. Even the hypothetical keyholes that once raised concerns for later dates, such as 2036, were ruled out by the updated orbital models. The asteroid will pass close, but not dangerously close, and it will not strike Earth in any of its foreseeable future encounters. Another crucial part of the scientific understanding involves the physical characteristics of Apophis. Knowing what an asteroid is made of, how it spins, and how its surface interacts with sunlight, is essential for predicting its motion over long periods. This is because even small forces can accumulate into significant changes in an asteroid's orbit. For example, the Yarkovsky effect, caused by the way an asteroid absorbs sunlight and re-emits it as heat, can gradually shift its path over years or decades. By studying Apophis's rotation, shape, and surface properties, scientists can account for these subtle influences and make more reliable predictions. Observations suggest that Apophis is an elongated, irregularly shaped body, likely composed of a mixture of rock and metal. Its rotation period and spin axis have been measured, allowing for more precise modeling of thermal forces. All of this information feeds into the larger effort to refine its orbit and reduce uncertainty. Beyond its physical properties and orbital mechanics, Apophis has become a central figure in discussions about how we monitor and prepare for potential asteroid threats. The asteroid has effectively become a case study in planetary defense. Its discovery highlighted how a relatively modest-sized asteroid could surprise us, and its subsequent observation campaign showed how international collaboration and persistent tracking can transform fear into knowledge. Today, there is a global network of observatories, both professional and amateur, that contribute to the ongoing effort to monitor near-Earth objects. Apophis has also inspired new missions such as NASA's OSIRIS-APEX, which plans to rendezvous with Apophis after its 2029 flyby. This mission will allow scientists to study the asteroid in detail, including how Earth's gravity may have altered its surface or internal structure during the close pass. These kinds of missions are not just about science. They are rehearsals for how humanity might respond if a truly dangerous asteroid were on a collision course with our planet. Equally important in the current approach is the way scientists communicate with the public. The early days of Apophis's discovery were marked by sensational headlines and widespread anxiety, often fueled by a lack of context or understanding. Today, agencies like NASA and ESA are more careful to explain probabilities, uncertainties, and timelines. They emphasize that while Apophis will come very close, it will not hit us, and that the event is a scientific opportunity rather than a crisis. This shift in communication helps prevent unnecessary panic, while still raising awareness about the broader issue of asteroid threats. It also underscores the importance of building trust between scientists and the public, since managing real risks in the future will depend on widespread cooperation and understanding. The fact that Apophis is now considered safe for the foreseeable future does not mean that the asteroid is unimportant. On the contrary, its 2029 flyby will be one of the most significant astronomical events of the century. The data collected during the encounter will help scientists refine models of how asteroids respond to gravitational interactions. When Apophis swings past Earth, our planet's gravity will alter its orbit slightly, providing a natural experiment in celestial mechanics. Observing these changes will improve our ability to predict the paths of other asteroids that may come close to Earth in the future. This knowledge is not just academic, it could one day make the difference between accurate warnings and missed threats. In this sense, Apophis represents not danger but preparation. By studying it closely, we are rehearsing for scenarios that could arise with less forgiving outcomes. Another element of the current understanding is the recognition that Apophis is part of a much larger population of near-Earth objects. Tens of thousands of asteroids cross our planet's orbit, and while most are smaller and pose little risk, some are large enough to be dangerous. The discovery of Apophis reminded the world that asteroid detection is an ongoing process. Even though we have now mapped a significant percentage of the largest near-Earth objects, many smaller ones remain undiscovered. Apophis serves as a reminder of the importance of continued investment in surveys, like NASA's upcoming NEO Surveyor mission, which will use infrared technology to detect asteroids that are difficult to spot with ground-based telescopes. The clarity we now have about Apophis is a testament to what is possible with focused effort. But it also points to the work still to be done in cataloging and tracking other potential threats. In the broader context of science and human society, Apophis illustrates the dynamic nature of knowledge. In 2004, it represented uncertainty, fear, and vulnerability. Today it represents understanding, preparedness, and opportunity. The shift from one to the other did not happen overnight, but through careful observation, collaboration, and persistence. It is a reminder that knowledge is not static, and that what seems threatening in one moment can become manageable in the next. It also underscores the importance of humility, because while Apophis is now understood to be safe, there may be future discoveries that once again raise unsettling probabilities. What matters is not whether we face risks, but how we respond to them. And the story of Apophis shows that humanity is capable of rising to that challenge. Ultimately, the current scientific understanding of Apophis offers a message of reassurance without complacency. We now know that in 2029, the asteroid will pass by harmlessly, offering a spectacular show in the sky, but no danger to life on Earth. We also know that this event will provide a treasure trove of scientific data, advancing our ability to track and predict asteroid behavior. Yet the larger lesson is that vigilance remains essential. The same tools and methods that gave us clarity about Apophis must be applied to the countless other objects that populate our cosmic neighborhood. We cannot let the relief of safety lead to the illusion of invulnerability. Instead, we must carry forward the momentum that Apophis created, building a future in which asteroid threats are met not with fear, but with readiness and confidence. In this way, Apophis is more than just a space rock passing by our planet, it's a symbol of our evolving relationship with the universe. The clarity we have today is a triumph of human curiosity, collaboration, and persistence. When Apophis sweeps past Earth in 2029, it will serve as a reminder of both the fragility of our world and the remarkable ability of our species to understand, prepare, and adapt. That, perhaps, is the most important element of all in our current scientific understanding of Apophis. Not just that we are safe, but that we are learning how to keep ourselves safe now and in the centuries to come. When scientists announced that Apophis would not strike Earth in 2029, there was a collective sigh of relief around the globe. But that reassurance did not erase every question. The cosmos is vast and unpredictable, and forecasting the path of an asteroid decades into the future involves much more than simply plugging numbers into a formula. Even though astronomers can now say with confidence that Apophis will not impact Earth during its 2029 close pass, there remain residual uncertainties that make this asteroid, and others like it, worthy of continued observation. These uncertainties do not mean we are in imminent danger, but they remind us that the universe is dynamic, that small influences can accumulate into significant effects over time, and that science requires humility in the face of the unknown. Understanding these uncertainties is not about fueling fear. It is about recognizing the limits of knowledge, preparing for unlikely but not impossible scenarios, and learning how to manage risk in a world that is constantly in motion. One of the first sources of uncertainty comes from the simple fact that no measurement is perfect. When astronomers track an asteroid, they record its position relative to background stars, and those positions are accurate to fractions of an arcsecond. But even the tiniest error in measuring an asteroid's position or velocity can grow over time as predictions are extended further into the future. This is because orbital dynamics are extremely sensitive to initial conditions. A small difference in starting position can, decades later, translate into a difference of thousands of kilometers in trajectory. Although the margin of error for Apophis's 2029 encounter has been narrowed significantly, projections for dates much farther into the future still carry wider error bars. This means that while 2029 is essentially safe, astronomers must keep watching Apophis over the years to ensure that no unforeseen deviations creep into its path. Another source of uncertainty lies in the subtle forces that act on asteroids beyond gravity. While the dominant force shaping an asteroid's orbit is gravitational attraction from the Sun, planets, and moons, non-gravitational effects also play a role. Chief among these is the Yarkovsky effect, a phenomenon in which an asteroid absorbs sunlight and re-emits it as heat. Because the asteroid is rotating, the heat is not radiated evenly, and this imbalance can act like a tiny thruster, gradually nudging the asteroid's path over time. The effect is minuscule on a day-to-day basis, but across decades it can shift an asteroid's orbit by kilometers or even more. Predicting the Yarkovsky effect requires detailed knowledge of an asteroid's rotation, shape, surface properties, and thermal characteristics. For Apophis, scientists have made great progress in understanding these factors, but some uncertainties remain. Small differences in assumptions about its thermal conductivity or surface roughness can change long-term predictions. While these changes are unlikely to create an immediate hazard, they highlight why continued observations are needed, particularly as Apophis's orbit evolves after the gravitational tug it will experience in 2029. That gravitational tug itself introduces another layer of complexity. When Apophis swings by Earth in 2029, our planet's gravity will alter its orbit slightly. Astronomers are confident it will not be directed into a collision course, but the exact details of the orbital change depend on precisely how Apophis passes relative to Earth. Will it swing 500 kilometers closer or farther from the center of Earth's mass than predicted? Even a difference of a few hundred kilometers can change the post-encounter orbit enough to matter when projecting decades into the future. This is why astronomers have identified keyholes, narrow regions in space such that if Apophis were to pass through one, Earth's gravity would redirect it toward a future collision. For Apophis, the most discussed keyhole once corresponded to a potential impact in 2036, but improved data have ruled that out. Still, the concept illustrates why precision matters. Space is full of gravitational pathways, and predicting exactly which one an asteroid will follow requires near-perfect measurements. Beyond natural forces, there is also the possibility of random events altering Apophis's path. For example, an impact by a much smaller meteoroid could impart a tiny change in velocity, enough to shift its orbit slightly. While the probability of such an event occurring and having significant consequences is extremely low, it cannot be ruled out completely. Space is not empty, and asteroids occasionally collide with smaller objects. Even if the collision does not break up Apophis, it could change its rotation or momentum just enough to alter its future trajectory. Another possibility, though equally unlikely, is that outgassing or internal stresses could shift the asteroid's spin state or surface, leading to subtle changes in how it absorbs and emits heat. None of these scenarios are probable, but they represent residual uncertainties that are impossible to eliminate entirely. It is also important to consider observational gaps. Apophis is not always visible from Earth. Its orbit takes it into regions where it is too faint or too close to the Sun to be observed effectively. During these gaps, small deviations in its path can accumulate unnoticed. When the asteroid becomes visible again, astronomers refine its orbit with fresh data. But in the meantime, predictions must carry assumptions. This is one reason why radar observations are so valuable. They provide snapshots of Apophis's exact distance and velocity when opportunities arise, dramatically reducing uncertainty. However, radar opportunities are limited by both the asteroid's distance and the availability of radar facilities. With the loss of the Arecibo Observatory in 2020, humanity lost one of its most powerful tools for asteroid tracking, which increases the importance of other facilities and the need to develop new capabilities. The uncertainties that linger around Apophis also extend to the broader context of planetary defense. While scientists are confident about Apophis's trajectory for the next century, it is just one member of a vast population of near-Earth objects, many of which remain undiscovered. The story of Apophis demonstrates how even a relatively large asteroid, over 300 meters across, can go unnoticed until only a few decades before a close approach. This raises important questions about the smaller, harder to detect asteroids that might cross Earth's orbit. The uncertainties surrounding Apophis serve as a reminder that our detection systems, while vastly improved, are still incomplete. Vigilance must extend to the entire population of near-Earth objects, not just the most famous or the largest ones. Another dimension of uncertainty is public perception. While scientists can quantify probabilities with great precision, the public often interprets risk in emotional rather than statistical terms. A 1 in a million chance of impact may sound reassuring to an astronomer, but to a layperson, it can still sound like a terrifying possibility. Conversely, the absence of immediate danger may lull people into complacency about long-term risks. The uncertainty here is not about the asteroid itself, but about how humanity will respond to evolving knowledge. Will we invest in planetary defense systems, even when no immediate threat exists? Or will interest fade once the drama of Apophis passes? The answers to these questions could shape our resilience to future asteroid discoveries more than Apophis's orbit ever will. Residual uncertainties also open the door to scientific opportunities. The close pass of Apophis in 2029 will allow astronomers to observe in real time how Earth's gravity reshapes an asteroid's orbit, rotation, and possibly even its surface. These observations will reduce uncertainties for Apophis and provide a template for analyzing other asteroids. For example, measuring how Apophis's spin changes after the encounter could refine models of the Yarkovsky effect. which in turn would improve predictions for thousands of other near-Earth objects. Thus, the uncertainties that remain today are not just sources of anxiety. They are also invitations to learn more and to transform unknowns into knowns. In the end, the story of residual uncertainties surrounding Apophis is one of perspective. From one angle, the asteroid represents a near miss that could have been catastrophic, and the lingering unknowns are reminders of how fragile our position in the solar system can be. From another angle, Apophis represents a triumph of science, where careful observation and modeling transformed a frightening possibility into a manageable reality. The uncertainties that remain are not signs of failure, but of the inherent complexity of celestial mechanics. They do not mean we should panic. They mean we should stay alert, continue refining our models, and treat each close encounter as both a challenge and an opportunity. To live with residual uncertainties is to accept the nature of science itself. Knowledge is never absolute. It is always provisional, always subject to refinement as new data arrive. Apophis may be the most famous asteroid of our time, but it is also a symbol of this broader truth: our safety depends not on eliminating all uncertainty, but on managing it wisely. The asteroid will pass us by in 2029, harmless yet humbling, a reminder that vigilance must be constant, that preparation is essential, and that the universe always holds surprises. The uncertainties surrounding Apophis are not causes for fear, but catalysts for progress, driving us to improve our detection systems, sharpen our models, and strengthen our resolve to be ready not just for Apophis, but for whatever else the cosmos may send our way. When we hear the name Apophis, our minds often go first to fear, the possibility of destruction, the nightmare scenario of an asteroid colliding with Earth. Yet beyond the drama of potential catastrophe lies another equally compelling narrative opportunity. The year 2029 will not be the year of Earth's doom, but rather a year in which humanity gains a once-in-a-lifetime scientific gift. When Apophis makes its close pass on April 13, 2029, it will come closer to Earth than many of our satellites, passing at a distance of about 32,000 kilometers. This is an astronomical rarity, the kind of cosmic alignment that only occurs perhaps once in thousands of years for an object of this size. Instead of being a cause for panic, it should be seen as an extraordinary chance to learn more about asteroids, planetary defense, and the dynamics of our solar system than we ever have before. Asteroids are relics from the birth of the solar system. They are fragments of the protoplanetary disk that never formed into planets, preserving within their rocky and metallic bodies the primordial ingredients of our cosmic neighborhood. By studying them, we peer back 4.6 billion years into the solar system's infancy. Space missions to asteroids, like NASA's OSIRIS-REx to Bennu or JAXA's Hayabusa to Ryugu, have already shown us that these bodies are not lifeless chunks of rock, but complex worlds with varied geology, chemistry, and even activity. Apophis offers the chance to study such an object not from millions of kilometers away, but practically on our cosmic doorstep, with Earth-based instruments operating at their maximum potential. Telescopes, radar facilities, and spacecraft will be able to gather a flood of data that would otherwise take decades and billions of dollars to obtain. The 2029 encounter represents a laboratory experiment on a planetary scale. Earth's gravity will not only bend Apophis's orbit, but may also affect its rotation, internal structure, and even surface features. Scientists expect that tidal forces, though not strong enough to tear the asteroid apart, could disturb the regolith on its surface, causing landslides or reshaping its contours in subtle ways. If such changes are observed, They would provide direct evidence of how celestial bodies respond to close planetary encounters. This knowledge would ripple outward to inform models of asteroid behavior in general, particularly those that might one day threaten Earth. In essence, Apophis allows us to test our theories under real-world conditions, turning abstract equations into observable phenomena. The scientific opportunities extend across multiple disciplines. For planetary geologists, Apophis is a case study in surface evolution. They will look for signs of seismic shaking, boulder movements, or changes in surface texture before and after the encounter. For astronomers, it is a test of orbital dynamics, where the precision of their models can be checked against actual measurements. For engineers, it provides a live environment to practice tracking and monitoring a near-Earth object at close range, sharpening skills that will be vital in any future planetary defense mission. Even biochemists and astrobiologists have a stake, since studying the composition of Apophis may shed light on whether such asteroids delivered water and organic molecules to early Earth, seeding the ingredients for life. Perhaps the most significant opportunity presented by Apophis lies in the realm of planetary defense. With a diameter exceeding 300 meters, Apophis is large enough that, if it were ever on a collision course with Earth, the consequences would be devastating on a regional or even continental scale. While it is not massive enough to cause a mass extinction event like the one that ended the reign of the dinosaurs, it could still flatten cities, trigger tsunamis, or disrupt the global climate. The fact that we now know Apophis will not hit Earth in 2029 allows us to treat its close approach as a safe practice run. We can use this event to test our systems, simulate emergency responses, and evaluate how well the global scientific community can coordinate in the face of a potential threat. This rehearsal is not just theoretical. NASA has already recognized the value of this opportunity. The OSIRIS-REx spacecraft, which recently returned samples from asteroid Bennu, has been reassigned and renamed OSIRIS APEX, with the APEX standing for Apophis Explorer. This mission will rendezvous with Apophis after its 2029 flyby, observing its rotation, composition, and structure in unprecedented detail. The mission is not just about gathering scientific data, it is about developing strategies. By learning how Apophis behaves up close, how it reacts to Earth's gravity, how its orbit evolves, how its material properties manifest, we equip ourselves with the knowledge to better deflect or mitigate future threats. In this way, Apophis becomes not a menace, but a mentor, teaching us how to handle its cosmic relatives that may cross our path in the future. The scientific opportunity also extends to education and public engagement. The 2029 flyby will be visible to the naked eye in some regions, turning millions of people into direct witnesses of a cosmic event. For many, it may be the first time they look up at the sky and see with their own eyes an asteroid gliding past Earth. This experience has the power to spark curiosity, inspire future scientists, and foster a sense of planetary unity. Schools, museums, observatories, and space agencies will undoubtedly seize the moment to involve the public, making 2029 not just a year of scientific observation, but of global scientific celebration. In a time when humanity often feels divided, Apophis offers a shared event that transcends borders and reminds us of our collective place in the cosmos. Yet, opportunity does not come automatically. It must be seized through planning, funding, and coordination. Telescopes must be prepared to devote observing time. Radar facilities must be calibrated and ready. Spacecraft must be positioned to take advantage of the encounter. Without deliberate effort, the moment could slip by, leaving only a fraction of the potential knowledge captured. The scientific community is well aware of this, and preparations are already underway. But it also requires political will, because planetary defense and asteroid research often compete with other priorities for limited budgets. Here lies another opportunity, not just scientific but societal. Apophis can be used as a rallying point to emphasize the importance of investing in planetary defense, ensuring that when a truly threatening asteroid does appear, humanity is not caught unprepared. The 2029 flyby will also challenge our technological capabilities. Tracking an asteroid at such close range, modeling its gravitational interaction with Earth, and deploying spacecraft to study it are not trivial tasks. Each step will push the boundaries of what we can do, sharpening the edge of our technological toolkit. This is not merely an academic exercise. The same tools that allow us to study Apophis could, in the future, allow us to divert a dangerous asteroid or even mine asteroids for resources. In this way, Apophis is a bridge not only to greater security but also to a broader economic and exploratory future. There is also an opportunity to deepen international collaboration. Asteroids, like pandemics and climate change, do not respect national borders. A strike anywhere on Earth would have consequences for everyone. The Apophis encounter provides a chance to practice working together as a planetary community. Data can be shared openly, missions can be coordinated across agencies, and communication strategies can be harmonized. If we can unite around Apophis, perhaps we can set a precedent for responding to other global challenges. The asteroid, ironically, could become a catalyst for human unity. On a philosophical level, Apophis also presents an opportunity to shift how humanity views itself. For centuries, people saw the heavens as distant and unchanging. But the reality is that Earth is part of a dynamic solar system, vulnerable to cosmic events, both small and large. Watching Apophis skim by will be a visceral reminder of this truth. It may provoke existential questions. Why are we here? How fragile is our place in the universe? How can we ensure the survival of our species against threats beyond our control? Such questions are not merely scientific. They are cultural, spiritual, and deeply human. Apophis's flyby can thus spark reflection as much as discovery, reminding us that we are both vulnerable and capable, insignificant in scale, yet powerful in ingenuity. Ultimately, the 2029 encounter with Apophis is not a threat to be feared, but a window to be embraced. It is a cosmic experiment, a scientific festival, a rehearsal for planetary defense, a technological test bed, and a moment of global unity. The asteroid itself is indifferent to our fate. It is a wandering rock following the laws of physics. But what we choose to do with its visit, that is entirely up to us. We can let it pass as a curiosity, or we can make it a turning point in our understanding of asteroids, our preparation for cosmic hazards, and our appreciation of the fragile, beautiful world we inhabit. Opportunity, after all, is not something that arrives gift wrapped. It is something recognized, grasped, and acted upon. Apophis in 2029 is such an opportunity. The question is, will we have the vision and courage to seize it? Preparedness and monitoring may not be the most glamorous aspects of space science, but when it comes to protecting Earth from asteroid threats like Apophis, they are absolutely essential. These two pillars, preparedness and monitoring, form the quiet backbone of our planetary defense. Preparedness is the plan we hope never to use, and monitoring is the vigilance that ensures we are never caught off guard. Together, they represent humanity's best defense against one of the few natural disasters that could, in theory, threaten not just a city or a country, but the entire planet. The close approach of Apophis in 2029 is a vivid reminder of how crucial these efforts are. while we now know it will not strike Earth during that encounter. The certainty we have achieved is the result of years of careful observation, technological advancement, and international cooperation. The story of preparedness begins with recognition. For most of human history, people did not even know asteroids existed, let alone that they could pose a threat to our world. The night sky was seen as eternal and unchanging. That illusion was shattered in the 19th century with the discovery of asteroids, and later by the realization that Earth bears the scars of past impacts. The massive Chicxulub crater in Mexico, linked to the extinction of the dinosaurs 66 million years ago, is a sobering reminder of the destructive power of such events. Preparedness today is born from that recognition. If it has happened before, it can happen again. But unlike the dinosaurs, we have telescopes, radar, spacecraft, and the ability to plan ahead. Preparedness is not about fear, it is about responsibility. Monitoring is where preparedness takes shape. It is the ongoing act of watching the skies, cataloging near-Earth objects, and refining their orbits. This is no small task. The solar system is vast, and space is filled with moving rocks, some as small as pebbles, others as large as mountains. The challenge is that even a relatively small asteroid, say 100 meters across, could cause catastrophic damage to a city or region. To date, astronomers have cataloged tens of thousands of NEOs, but there are many more to find. Apophis was discovered only in 2004, a startling reminder that objects capable of posing global hazards can remain hidden until surprisingly close to Earth. Monitoring means we must never stop looking, because what we do not see could hurt us most. When Apophis was first discovered, the monitoring process did exactly what it was designed to do: detect, measure, and assess risk. Early calculations suggested a concerning probability of impact in 2029, about 27%, far higher than any asteroid risk ever calculated at the time. That number alarmed both the scientific community and the public. But as more observations were gathered, the orbit was refined and the risk dropped to zero. This is monitoring in action, not just discovering an object, but tracking it over time, reducing uncertainties, and moving from fear to clarity. The lesson here is profound. Without monitoring, we would live in ignorance, unable to distinguish real threats from imagined ones. Monitoring turns speculation into knowledge, and knowledge is the foundation of preparedness. Preparedness goes beyond simply knowing where an asteroid is. It is about having strategies for what to do if a dangerous one were indeed headed our way. For Apophis, 2029 is safe, but what if it were not? This is where global space agencies have begun to take concrete steps. NASA has established the Planetary Defense Coordination Office, tasked with detecting, tracking, and characterizing potentially hazardous objects. The European Space Agency is developing its own planetary defense programs, with missions like Hera designed to study asteroid deflection. International efforts are coordinated through networks, such as the International Asteroid Warning Network and the Space Mission Planning Advisory Group, both supported by the United Nations. These structures ensure that monitoring data is shared globally, and that preparedness strategies are discussed across borders. After all, an asteroid does not care about national boundaries. It is a planetary problem that demands a planetary response. Preparedness also includes testing our ability to deflect or mitigate a threat. In 2021, NASA launched the Double Asteroid Redirection Test Mission, which deliberately impacted the small asteroid moon Dimorphos to test whether a kinetic impactor could alter its orbit. The mission was a success, shortening Dimorphos's orbital period around its larger companion, Didymos, by 33 minutes. This was the first time humanity demonstrated a planetary defense technique in space. The lesson of DART is that preparedness is not just theoretical, it is practical. It is the difference between hoping we could deflect an asteroid and proving that we can. Apophis offers the opportunity to extend this kind of preparedness by allowing us to practice monitoring a large, close, passing asteroid in real time. While we will not attempt to deflect Apophis, it poses no threat. The data we collect will help refine deflection strategies for future asteroids that may not be so cooperative. Monitoring Apophis specifically has been a triumph of modern astronomy. Radar observations have been crucial in pinning down its orbit. When Apophis passed Earth in 2013 and again in 2021, radar facilities provided precise measurements of its position and velocity. These observations ruled out any possibility of impact in 2029 or 2036 and extended predictions far into the future. The tragic collapse of the Arecibo Observatory in 2020 was a loss to this effort, as Arecibo had been one of the most powerful radar facilities for asteroid tracking. But other observatories, like NASA's Goldstone facility, continue the work. These facilities are essential not only for Apophis, but for all potentially hazardous asteroids. Preparedness requires more than just technology and observation. It also depends on effective communication. When Apophis was first discovered and its potential impact risk was publicized, it triggered a wave of anxiety and speculation. Some headlines exaggerated the threat, while others downplayed it, highlighting the delicate balance between warning the public and avoiding unnecessary panic. In the realm of planetary defense, how we communicate risk is just as important as how we measure it. Preparedness means having clear protocols for informing governments, the media, and the public about asteroid threats in a way that builds trust and encourages constructive action. Apophis provides a unique opportunity to refine these communication strategies. In 2029, as millions of people watch the asteroid pass by, scientists and officials will have the chance to practice sharing information in real time, ensuring that in a future scenario involving a genuine threat, communication is effective rather than chaotic. The lessons learned from Apophis can help shape how we handle not only asteroid risks, but also other global challenges that require coordinated public messaging. Monitoring and preparedness also involve considering the long-term evolution of Apophis's orbit. While the 2029 encounter is safe, the asteroid will be significantly deflected by Earth's gravity during the flyby. Predicting its new orbit with precision requires ongoing observations both before and after the event. Small forces, such as the Yarkovsky effect, caused by uneven heating and radiation of sunlight, can gradually shift its path over time. By monitoring Apophis for decades, scientists can track these subtle influences and ensure that no future keyholes, narrow gravitational pathways leading to potential impacts, remain unexamined. Preparedness, in this sense, is not a one-time declaration of safety, but a continuous process of vigilance. Just because Apophis is harmless in 2029 does not mean we can stop paying attention. Monitoring is a never-ending task. The encounter with Apophis also offers preparedness in practice, not just in theory. Spacecraft like NASA's Osiris APX, which will study Apophis after the flyby, will provide detailed data on its shape, rotation, and composition. This information feeds directly into preparedness models. For example, understanding how much force would be needed to deflect it if it were a threat, or how strong its internal structure is. Would it hold together or fragment under stress? What surface properties affect the Yarkovsky effect? By answering these questions, Apophis becomes a training ground for planetary defense. It is not just about Apophis itself, but about every other asteroid we might one day encounter. Preparedness is about being ready not just for the known, but for the unknown. Monitoring also requires global participation. While NASA and ESA lead many efforts, smaller observatories, universities, and even amateur astronomers contribute data that refines asteroid orbits. Preparedness is thus not the work of a few nations but of a global community. In 2029, astronomers around the world will point their telescopes at Apophis, each observation adding to the collective effort. This spirit of cooperation is itself a form of preparedness, demonstrating that humanity can come together to face a common cosmic challenge. In a world often divided by politics, economics, and ideology, Apophis reminds us that some problems can only be solved collectively. Preparedness at its heart is about resilience. It is the recognition that while we cannot control the universe, we can control how we respond to it. Monitoring gives us time, and time is the most valuable resource in planetary defense. With decades of warning, even a large asteroid could be deflected or mitigated. Without warning, even a small one could cause devastation. Apophis shows us that preparedness works. From initial alarm to confident reassurance, we have navigated the challenge with science, observation, and coordination. The 2029 flyby will be a vivid demonstration that preparedness is not paranoia, it is prudence. In the end, Apophis is not just a rock hurtling through space. It is a teacher. It teaches us the value of vigilance, the necessity of preparation, and the importance of humility before the cosmos. Preparedness and monitoring may lack the glamour of exploration, but they are no less heroic. They are the quiet guardians of our world, ensuring that the sky above us remains a source of wonder rather than fear. When Apophis passes by in 2029, it will not bring destruction, but it will bring a lesson that safety is not given. It is earned through constant observation and careful planning. If we embrace that lesson, Apophis will not be remembered as a threat, but as a turning point in humanity's journey to take responsibility for its place in the universe. When discussing Apophis and its 2029 encounter with Earth, much of the conversation tends to focus on scientific details, orbital mechanics, gravitational interactions, and planetary defense strategies. Yet, one of the most important dimensions of this event is not technical at all. It is human. It is about how people perceive the asteroid, how emotions shape reactions to risk, and how society at large interprets the meaning of such a cosmic near-miss. Public perspective is as vital to the conversation as the mathematics of Apophis's orbit. Science does not exist in a vacuum. The way information is communicated, understood, and acted upon by humanity will determine whether this event fosters panic, indifference, or inspiration. Asteroids, after all, are not only astronomical objects. They are cultural events, stories that ripple through human consciousness. The story we tell about Apophis will matter as much as the science itself. When Apophis was first identified in 2004, the initial estimate of a roughly 2.7% chance of impact in 2029 quickly made its way into headlines around the world. News outlets and television programs painted vivid pictures of disaster, cities wiped out, global chaos, and the so-called doomsday asteroid. For many people, the technical details of orbital probabilities and statistical refinement were less important than the simple phrase, "Asteroid could hit Earth." Fear spread rapidly, amplified by dramatic media coverage and the natural human tendency to focus on worst-case scenarios. This episode revealed something fundamental about how the public perceives risk. People tend to respond more strongly to the possibility of disaster than to the actual probability. A scientist might emphasize that a 1 in 40 chance of impact is still overwhelmingly unlikely, but a member of the public may hear only chance of impact and immediately imagine catastrophe. Risk, in the human mind, is not always processed as a number. It is filtered through emotions, biases, and imagination. This disconnect between scientific communication and public understanding is not unique to asteroids. It is evident in many areas, from climate change to public health. But with asteroids, the imagery is especially powerful. The idea of a rock from space slamming into Earth taps into deep, almost primal fears of sudden catastrophe, of forces beyond human control, of extinction itself. In this way, Apophis became a mirror reflecting how humanity grapples with vulnerability. The public perspective is not just about whether people are worried. It is about how humans confront the reality of living on a fragile planet in a dynamic solar system. Fortunately, as more data came in and the risk for 2029 was ruled out, the tone of public conversation shifted. The sense of impending doom was replaced by curiosity and even excitement. Articles began to highlight that Apophis would pass closer than some satellites, that it might be visible to the naked eye, and that scientists were eager to study it. Fear gave way to fascination. This transformation underscores another truth. Public perspective is malleable. It can swing from panic to awe depending on how information is presented. The same asteroid can be framed as a harbinger of destruction, or as a cosmic visitor offering a front row seat to the wonders of the universe. The challenge, then, is one of narrative. Do we let Apophis become a story of dread, or do we choose to tell it as a story of opportunity and resilience? Public perception is also shaped by trust, or the lack of it, in scientific institutions. When the news of Apophis's possible impact first spread, some people questioned whether authorities were telling the whole truth. Would scientists warn the public if a collision were inevitable? Would world leaders try to cover it up to prevent panic? These suspicions highlight a deeper issue: transparency in planetary defense. If the public feels that information is being hidden or manipulated, panic and conspiracy theories can thrive. Conversely, when scientists are open, clear, and consistent in their communication, trust grows. The case of Apophis offers an opportunity to strengthen this trust by keeping the public informed, explaining uncertainties honestly, and engaging people with educational outreach. The event can reinforce confidence in science rather than erode it. The 2029 flyby also has the potential to become a cultural phenomenon. For the first time in recorded history, a large asteroid will pass close enough to Earth to be visible to the naked eye in certain regions. Millions of people will be able to look up and see Apophis streak across the sky, a bright point of light that represents both danger and discovery. This is not just a scientific event, it is a shared human experience. Much like solar eclipses captivate crowds and inspire awe, Apophis has the chance to unite people in wonder. In this case, public perspective may not be about fear at all, but about beauty, curiosity, and a renewed sense of connection to the universe. The way institutions and educators frame this experience, through broadcasts, citizen science programs, and public events, will shape how people remember it. Will it be remembered as a near disaster narrowly avoided, or as a night when humanity collectively looked up and marveled at the cosmos? Education plays a central role in shaping public perception. For many young people, the 2029 flyby will be their first vivid encounter with the reality of near-Earth asteroids. Classrooms will use the event to teach about planetary science, orbital mechanics, and Earth's history of impacts. Teachers will explain that asteroids are not just threats, but also sources of knowledge about the early solar system. Museums and science centers will create exhibitions, live streams, and outreach campaigns. By framing Apophis as a learning opportunity, educators can transform anxiety into empowerment. The message becomes not, "We are helpless against cosmic threats," but, we are learning, preparing, and growing as a species. This subtle shift in perspective could inspire the next generation of scientists and engineers who will lead future planetary defense efforts. Public perspective is also influenced by cultural storytelling. Movies like Armageddon and Deep Impact have already shaped how people imagine asteroid encounters, desperate missions, last-minute heroics, and global panic. These narratives are dramatic, but they are also misleading. They create the impression that asteroid defense is about Hollywood-style rescues rather than long-term preparation and monitoring. Apophis offers a chance to reshape the cultural story. Instead of fear-driven narratives, humanity can emphasize stories of cooperation, foresight, and scientific triumph. Documentaries, books, and even fictional portrayals can highlight how Apophis is not a disaster, but a demonstration of human ingenuity and global coordination. The story we tell matters, because it influences public support for funding, research, and international collaboration. At the same time, it's important to recognize that some members of the public will always cling to fear, no matter how much reassurance scientists provide. There will always be those who believe that authorities are hiding the truth, or that Apophis's orbit could suddenly change in some unpredictable way. The internet accelerates the spread of such anxieties, creating echo chambers where conspiracy theories can flourish. In this sense, preparedness is not just about telescopes and spacecraft, it's also about combating misinformation and building public resilience. Communication strategies must anticipate myths, counter them with facts, and engage with people respectfully. Ignoring or dismissing fear only deepens mistrust. Acknowledging uncertainties while clearly explaining probabilities builds credibility and trust. The 2029 event will test humanity's ability, not just to track an asteroid, but to manage the flow of information about it in a digital age. The way the story of Apophis is told, by scientists, educators, journalists, and leaders, will shape how people respond, not only to this event, but to future cosmic threats as well. If the narrative is dominated by fear and sensationalism, it could undermine public confidence in science and planetary defense. If, instead, the story is one of curiosity, preparation, and global cooperation, it can inspire a sense of agency and unity. Public perspective also ties into the larger question of how humanity views existential risk. Apophis is a reminder that our planet is not invulnerable, that cosmic hazards exist whether we think about them or not. For some, this realization is unsettling. For others, it is galvanizing. It can prompt a sense of humility, a recognition of our fragility in the face of the universe. But it can also inspire a sense of agency, a belief that, unlike the dinosaurs, we are capable of foresight and defense. How the public interprets this will influence political will. Governments respond to public opinion, and public opinion often determines budgets. If people see planetary defense as a distant or irrelevant concern, funding will stagnate. If they see it as essential to the survival of civilization, support will grow. Thus, public perspective is not just a matter of psychology. It is a driver of policy. In 2029, when Apophis makes its closest pass, the public perspective will likely be a mix of awe, anxiety, and curiosity. Some will watch with wonder, others with fear, and many with indifference. But in that moment, humanity will share a common experience, the awareness that we live on a small planet in a vast, dynamic universe. Whether people interpret that awareness as frightening or inspiring will depend on how leaders, educators, scientists, and communicators frame the event. It is an opportunity to promote not panic but unity, not helplessness but readiness. If framed wisely, Apophis can shift public perspective toward seeing planetary defense as a shared responsibility, a symbol of what humanity can achieve when it acts together. Ultimately, public perspective on Apophis is about narrative control. Fear and fascination are both possible outcomes, but the choice is ours. The asteroid itself is indifferent, an inanimate traveler on a cosmic path. It is humanity that decides whether to see it as an omen of doom, or as a teacher, a reminder, and an inspiration. If we choose fear, we learn nothing. If we choose curiosity, we grow stronger. If we choose responsibility, we become safer. In this sense, Apophis is not just a test of astronomy, it is a test of storytelling, of communication, and of collective imagination. The 2029 fly will pass in a matter of hours, but the public perspective we build around it could last for generations. The real question is not whether Apophis should concern us, but how we choose to see it. Do we see the shadow of catastrophe, or do we see the light of opportunity? The answer lies not in the stars, but in ourselves. As the date of the close approach draws nearer, preparations are intensifying on multiple fronts. Scientists are finalizing observation schedules, ensuring that telescopes and radar facilities around the world are ready to capture every possible detail of Apophis's flyby. Space agencies are coordinating to share data in real time, and educational institutions are developing outreach programs to engage the public. The event is being treated not just as a scientific opportunity, but as a moment to foster global awareness and cooperation. The flyby will also serve as a real-world test of our planetary defense infrastructure. It will allow agencies to practice rapid data analysis, cross-border communication, and public information campaigns. These exercises are invaluable, because in the event of a future asteroid threat, the ability to act quickly and in concert could make all the difference. Apophis, in this way, is helping to build the muscle memory of planetary defense, ensuring that when a real emergency arises, humanity is not starting from scratch. The 2029 encounter is also prompting new research into asteroid deflection techniques. While Apophis itself poses no danger, its close approach is a perfect opportunity to model how different intervention strategies might work. Scientists are using computer simulations to test the effectiveness of kinetic impactors, gravity tractors, and other methods. These studies are not just academic, they are laying the groundwork for future missions that could one day save lives. The lessons learned from Apophis are already shaping the future of planetary defense. As the world prepares for the 2029 flyby, the scientific community is not only focused on the technical aspects of tracking and studying the asteroid, but also on building the frameworks that will allow for rapid, coordinated responses to any future threats. This means developing better early warning systems, improving international data sharing, and refining the protocols for decision-making in the face of uncertainty. The experience with Apophis has shown that time is the most valuable asset in planetary defense. The more warning we have, the more options are available, whether it's deflection, evacuation, or mitigation. One of the most important outcomes of the Apophis story is the recognition that planetary defense is a global responsibility. No single nation can monitor the entire sky or respond to a threat alone. The networks and partnerships that have grown around the study of Apophis, such as the International Asteroid Warning Network and the Space Mission Planning Advisory Group, are models for how the world can work together to address shared risks. These organizations facilitate the exchange of observations, coordinate research efforts, and help ensure that the best available science informs policy decisions. The 2029 flyby will be a test of these systems, providing a real-world scenario in which to practice and improve international cooperation. The event is also driving innovation in technology. The need to track Apophis with high precision has led to advances in radar imaging, optical tracking, and data analysis. These improvements will benefit not only asteroid monitoring, but also other areas of astronomy and space science. The Asteroid Apophis mission, for example, will demonstrate new techniques for rendezvousing with and studying a fast, moving object in deep space. The knowledge gained from this mission will inform the design of future spacecraft, whether for scientific exploration, resource utilization, or planetary defense. Beyond the technical and organizational advances, Apophis is also influencing the way scientists and policymakers think about risk. The initial alarm over a possible impact, followed by the gradual reduction of that risk as more data became available, is a powerful example of how science works in practice. It shows the importance of transparency, the need for ongoing observation, and the value of updating assessments as new information comes in. It also highlights the challenge of communicating uncertainty to the public, how to be honest about what is not known, without causing unnecessary fear or complacency. The 2029 flyby will be a moment of global attention, but the work of planetary defense will continue long after Apophis has passed. The event will generate a wealth of data that will be analyzed for years to come, improving our understanding of asteroid dynamics and the effectiveness of different monitoring strategies. It will also serve as a catalyst for continued investment in sky surveys, radar facilities, and space missions. The momentum generated by Apophis can help ensure that planetary defense remains a priority, even when there is no immediate threat on the horizon. Culturally, the Apophis encounter is likely to leave a lasting mark. For many people, seeing an asteroid with the naked eye will be a once-in-a-lifetime experience, one that sparks curiosity and wonder about the universe. The event will be covered by media outlets around the world, featured in documentaries, and discussed in classrooms. It will become part of the collective memory, a story told to future generations about the time when a god of chaos passed close by, and humanity watched, learned, and prepared. The flyby also offers a chance to reflect on our place in the cosmos. It is a reminder that Earth is not isolated, but part of a dynamic, and sometimes unpredictable solar system. The same forces that shaped the planets and moons billions of years ago are still at work today. By studying Apophis, we are not only protecting ourselves from potential harm, but also deepening our understanding of the universe and our connection to it. In the years following the 2029 encounter, the data collected will help refine models of asteroid behavior, improve predictions for other near-Earth objects, and guide the development of new technologies for monitoring and deflection. The lessons learned will be applied to future discoveries, ensuring that the next time a potentially hazardous asteroid is found, humanity will be even better prepared. Ultimately, the story of Apophis is one of progress. It is a testament to what can be achieved when science, technology, and international cooperation come together to address a common challenge. The asteroid's close approach is not just a test of our readiness, but a celebration of our ability to learn, adapt, and protect our world. As we look to the future, Apophis serves as both a warning and an inspiration, a reminder that vigilance, preparation, and unity are the keys to safeguarding our planet. As the world looks ahead to the 2029 flyby, the legacy of Apophis is already clear. It has transformed from a source of fear into a catalyst for scientific advancement, international collaboration, and public engagement. The asteroid's journey through our cosmic neighborhood has prompted new questions, inspired new technologies, and reminded us of the importance of vigilance in a universe that is both beautiful and unpredictable. The close approach of Apophis will be more than just a spectacle in the night sky. It will be a living demonstration of how far humanity has come in understanding and managing the risks posed by near-Earth objects. The event will showcase the power of global networks, scientists, engineers, educators, and ordinary citizens working together to observe, analyze, and learn from a celestial visitor. It will also highlight the importance of sustained investment in research, technology, and education, ensuring that the next generation is even better equipped to face whatever challenges the cosmos may present. In the aftermath of the flyby, the data collected will continue to yield insights for years to come. Scientists will pore over measurements of Apophis's altered orbit, its surface changes, and its response to Earth's gravitational pull. These findings will refine our models of asteroid dynamics, improve our ability to predict future encounters, and inform the design of new missions aimed at both exploration and planetary defense. The lessons learned from Apophis will ripple outward, influencing how we approach other near-Earth objects and how we prepare for the unknown. But perhaps the most enduring impact of Apophis will be the way it changes our perspective. For a brief moment, people around the world will look up and share a sense of wonder, and perhaps a touch of humility, at the realization that our planet is not isolated but part of a vast and dynamic solar system. The asteroid's passage will remind us that while we cannot control the universe, we can control how we respond to its challenges. Through science, cooperation, and foresight, we can turn potential threats into opportunities for growth and discovery. The story of Apophis is ultimately a story of awakening. It began with a faint point of light in the Arizona sky and grew into a global conversation about risk, resilience, and responsibility. It has shown that knowledge is our greatest shield, that preparation is our best defense, and that unity is our strongest asset. The asteroid's close approach is not the end of the story, but a new chapter in humanity's ongoing journey to understand and protect our world. As we move forward, the lessons of Apophis will continue to guide us. We will keep scanning the skies, refining our models, and building the tools needed to safeguard our planet. We will teach future generations, not just to fear the unknown, but to explore it, to question it, and to rise to its challenges. The universe will always hold surprises, but with each new discovery, we become a little more prepared, a little more connected, and a little more aware of our place in the cosmos. When Apophis sweeps past Earth in 2029, it will leave behind more than just data and memories. It will leave a legacy of curiosity, collaboration, and courage. It will remind us that even in the face of uncertainty, humanity has the capacity to learn, adapt, and thrive. The asteroid's journey is a testament to the power of science and the spirit of cooperation, a beacon for all who look to the stars and wonder what lies ahead. In the end, Apophis is not just an asteroid. It is a symbol of our shared journey, a journey marked by discovery, by vigilance, and by hope. As we watch it pass, we are reminded that our greatest strength lies not in denying the risks we face, but in meeting them with open eyes, open minds, and a determination to build a safer, wiser future for all.